Hello, today we're looking at adding and subtracting in algebra. This is very similar to adding and subtracting anything in the real world. So we have two number lines down the bottom with the same calculation. Our calculation on the left here has no variables in it, so just like we would have learned when we were very young, starting at 2, we're adding 4, we're moving 4 spaces to the right in a number line, and we end up at 6. So that's quite straightforward. The addition of the variables on the right hand side here, that would intimidate some students, but really there's no need to worry about it. We do it in the exact same way. We can see the number line is identical. We're starting at 2, we're adding 4 of the same variable, so we're moving 4 spaces to the right, and we're stopping at 6. So it's 2y plus 4y, it gives us 6y, so it's the exact same thing. So that's kind of an example, but we've got, I think, 5 more examples to go. Number 1 here, we can see it's 9 take away 5 is 4, and we can follow the number line, start at 9, move 5 spaces to the left, and we stop at 4. So on the right hand side we have the algebra. We can draw a number line, but it will be the exact same number line as we had over here. So we're still going to go from 9, 5 spaces to the left, and stop at 4. So it's going to be 4t. Now, of course, 4t just means 4 multiplied by t. Whatever value t has, we don't know. T is our variable. The example down below, number 2. Minus 3 plus 7. Slightly harder, as in minus 3 is to the left of 0. And adding 7, we're moving 7 spaces to the right, so we pass by 0, stopping at 4. Again, we need to be careful to follow that on our number line. So if you're unsure, always use a number line or a calculator. So if we add a variable, does it make any difference? Just because we have m here? No, still the exact same number line. We're still starting at minus 3. Still moving 7 spaces to the right. I'm still going to stop at 4. So it should be 4m. So the variable doesn't really matter in terms of how we calculate the addition or subtracting on a number line. The only thing to remember is that m is a variable and m is multiplying 4. So if we know the value of m, if m was, for instance, 2, then it would be 4 times 2 would be 8. So that's if m was 2, but m could have any value, so we really don't know what it is. But for adding and subtracting, we can see that the algebra terms don't really make any difference. Our third example, 2 minus 5, so 2, we're starting on the right hand side here, we're right of 0. We're subtracting 5, so we're moving to the left, going 5 spaces, and we're stopping at the minus 3. So we should be able to follow that on our number line. So if we add a variable in there, again, that's not going to make any difference. This time we've gone for a, so it's 2a, take away 5a, and our answer is going to be minus 3a, using the same number line. So on to our next example. We have minus 6 plus 4. So minus 6, we're starting on the left hand side. We're adding 4, so it means we're moving to the right. And counted 4 spaces, we should stop at minus 2. So again, doesn't matter what variable we use. We're starting at minus 6, we're adding 4, we're going to end up at minus 2. So f, our variable is f, not going to make any difference. This is going to be equal to minus 2f, just following the same number line. So again, use your calculator if you're unsure, or a number line. This is number 6 really, I suppose, should be number 5. So we have minus 8 minus 3. So we're starting at minus 8. We're going to subtract 3. So we're moving to the left. And that means we're going to stop at the minus 11 here. So again, doesn't matter what the variable is here, it's p. So it's minus 8p minus 3p should be equal to minus 11p. So we can see the algebra is not making any difference really. And we're also seeing the adding, we're stepping to the right, subtracting, we're stepping to the left. It's quite easy. So what have we learned? If we take the time to draw a number line, adding and subtracting is easy, I suppose. Not that easy. What if I am asked to add something like 2x plus 3x plus 8y? That looks a bit more complicated. We've got two variables. All of our problems beforehand, I'd only got one variable. I've got an x here. I have a second x over here. So they're the same type of variable, but then we have a y. That's changing things quite a bit. So how do we do it? Should our answer be 5x plus 8y? Should it be 13xy, 13x, or 13y? Well, we'll have to investigate to figure out which one of these is the correct answer. It all comes down to how big is x and how big is y and so on. So let's just imagine for a moment x is 7 and y is 500. So our problem becomes 2 times x, that's just 2 times 7. The 3x, well, that's just the same as 3 times 7. And 8y, that's just the same as 8 times 500. So if we do this calculation, we should know what the correct answer should be. So 2 times 7, 14. 3 times 7, 21. 8 times 500, 4,000. We can add all that up. That's 14, 21 is 35, plus the 4,000. We're getting a total of 4,035. Okay, so that's what the answer should be, so long as, or if, x is 7 and y is 500. So would any of these suggested answers give us 4,035? Let's consider that. I've posed that question in a slightly different way. How does this help? So we had our 4 possibilities that we were considering. Do any of these lead to the answer 4,035 when x is 7 and y is 500? Starting with the first one. So 5x plus 8y. So 5x plus 8y, we're doing that up here. 5 times 7, 35. 8 times 500 is 4,000. And we're adding those, we're getting 4,035. That's the right answer. That's great. So it looks like we've got it right first time. But let's just check the other answers. So the 13xy. Yes, that's 13 times 7. X is 7 and y is 500. So it's 13 times 7 multiplied by 500. That works out as 45,500, and it's just too big. So we know that that answer is definitely not correct. So our first answer is looking good and the second answer is looking bad. 13x in the same way. That's just 13 times 7 is 91. It's far too small. We know the answer should be 4,035. So we can see our third answer is wrong. And the 13y, 13 times 500 because it's 6,500. It's too big. So again, just not getting the answers we need. So we can see that that last answer is also wrong. So what have we learnt? We've learnt we can add the x's. Going back to our original problems, we can add the 2x and the 3x to get the 5x. That's okay. But we shouldn't go adding the x's and the y's. That's what our work has shown us. So this tells us we cannot add x and y. Can I add x and x squared? Let's try this question here. 3x to the power 1 plus 2x squared. Now up here I didn't show the power 1. Here I did. That doesn't make any difference. We're just very lazy about showing the power 1. We often leave it out. Usually it's left out. But can I add something like 3x and 2x squared? Or 3x to the power 1 plus 2x squared? Can we add these? Well, some possible answers, maybe some people might say, well, that should be 5x cubed, or should just be 5x, or should be 5x squared, or we can't add them at all. So what's the truth? Again, if we look at each calculation, we should have a better idea. Let's investigate a little bit. We'll start up here with our investigation again. We'll start off, what if x was 5? Okay, so we're going to start with that. What if x was 5? So we're replacing x with 5, and here we're also replacing the x with 5. The only difference is one of them has power 1, the other has power 2. So our first one, 5 to the power 1, is just 5. That doesn't change. The second one though, 5 squared is 5 multiplied by 5, that's 25. So with the powers out of the way, that's the O in BOMDAS, or if you use the word BEMDAS, maybe some people use the word BEMDAS. E is for powers or exponents. Some people use BIMDAS. I is for powers or exponents or indices. So anyway, the powers are done. Now we can get on with multiplying. So it's 3 times 5 is 15. 2 times 25 is 50. And then finally 15 plus 50 is 65. We know that's the correct answer. The answer should be 65, but we had suggested over here, there was some suggested possible answers. Investigating each of these, none of them work. So really the last answer where we don't add them is the way to go. But we can see the work there in that kind of pinky pen, but our substituting in our black number 5, because we suggested the x can be 5 for the purpose of this investigation. So over here when we're doing the cubed, 5 cubed means 5 by 5 by 5. 5 times 5 times 5. That is 125. So that's where 125 comes from. Still need to multiply that by the 5 that's outside the bracket. And so that gives a total of 625, and we can see it's wrong. We know the answer should be 65. Second suggestion was the answer might just be 5x. We can see 5 times, if x is 5, it's 5 times 5 is 25. We can see that's also wrong. We know the answer should be 65. Similarly to the last one, 5x squared is a suggestion. So x squared would be 5 squared there, the black 5 getting squared. So 5 squared, 5 times 5 is 25. And then we need to multiply by the 5 outside the bracket, giving us 125. So also not right, we know the answer should be 65. So what have we learnt? So now we know, we also know x and x squared should not be added. So if the powers are different, we can't go adding them. We say only like terms can be added and subtracted. This here is our rule for adding and subtracting in algebra. We can only add or subtract like terms. So some examples of like terms. 6x plus 2x, they're like terms. We can add those. 8x. Next one, 14y minus 10y, they're similar. They're the same type of terms that are like terms. Subtract those and we get 4y. So there's 2 examples done. Third example, 20m, take away 30m. So they're the same variable m, same powers. We can subtract these. 20 take away 30 is minus 10. So it's minus 10m. Next one, 7x squared plus 3x squared. It's the same variable x. They both have the same power squared, so these can be added. 7x squared plus 3x squared is 10x squared. Next one looks a little bit trickier. So this is looking a little bit tricky. We have a y squared x, but we can see it's 8y squared x take away 6y squared x. So they've got the same variables and the same powers. The y's are squared in both terms. The x is a power of 1 in both terms. So these can be subtracted. 8 take away 6 is just 2. That's pretty straightforward once we take the time to look at it. The last one might confuse people in that the variables have been reversed, or the order of the variables is reversed. We've got AB and BA. However, they're the same variables. There's an a in both terms, there's a b in both terms. The a is a power of 1 in both terms, and the b is a power of 1 in both terms. So it's the same variables, same powers. These can be added. 3 plus 5 is going to be 8. Now, should I call it 8ab or 8ba? It actually doesn't matter. They're the same thing. So that's what we're pointing at here. So whichever you feel happier using. What can we say about these like terms? Like terms have the same variables and the same powers. Must have the same variables and the same powers. So taking a look at some examples of unlike terms, and remember these cannot be added or subtracted. So we should not be adding and subtracting these. So you can see we haven't equals to anything because these just cannot be added. So it's 2x and 5a. The variables are different. I don't know what the value of x is, don't know what the value of a is, and it's unlikely they're the same value. They could be, of course, but so I can't go adding these. Similarly, in the second problem there, 3m plus 4s, different variables, can't go adding them. Third example, 18am minus 2a. Okay, so they both have an a in each term, but the first term has an m and the second term has no m, so it's a different combination of variables. These can't be added. Going to the next one, they've got the same variable x but different powers. So the first one is an x squared, the second one is an x cubed. So they're not like, they're unlike, we call them. They can't be added. Next ones look almost the same, but again they've got y's in both terms, but the first y is a y cubed up there, while the second y is a y squared. So the powers are different. We can't go ahead in these. And the last one's perhaps the most confusing of them. We have an 8xy squared adding 2x squared y. So the same variables x and y appear in both terms. However, the powers are different. In the first term, x is a power of 1. In the second term, x is a power of 2. So the powers are different. So looking at the y's then, first term y is a power of 2, and the second term has got a power of 1. So again, the powers are different. So we can't go adding these. So there's some examples of unlike terms that should not be added or subtracted. Unlike terms have different variables or different powers, and we shouldn't be adding and subtracting them. Notice the word or there. So the word or here. So if the variables are different, they're unlike, regardless of the powers. If the variables are the same but the powers are different, then they're not like terms. So basically both criteria here, either one of these criteria will knock it off, so they're not like terms. So the word or is very different to the one up here where we have the word and. So that's a key difference in our definitions. So like terms have the same variables and the same powers. Unlike terms have different variables or different powers, or both. So hopefully that helps with adding and subtracting different terms. Get plenty of practice. Thanks for watching and thanks for listening. Good luck with your work. Bye bye.